everyone. So in today's video we are going to solve real number system, and for that I have four questions for you. We will solve them one by one. So these questions help us understand the rational numbers and irrational numbers in a better way. Let's start with question number 1. Question number 1 is, find any four rational numbers between 2 by 5 and 1 by 2. So for that we should know that there are infinite rational numbers between 2 by 5 and 1 by 2. So but how can we name four rational numbers? So for that, let's convert them into the decimal first, so that we have an idea that what are these two fractions equal to. So if I convert 2 by 5, if I convert 2 by 5, so 2 by 5 is equal to 4 by 10. This is equivalent fraction, and this is in decimal 0.4. And if I say 1 by 2, we all know it's very common fraction, it is equal to 0.5. So it means that I need to write down three rational numbers between 0.4 and 0.5, so I can enhance the decimal points between these two to get my answer. So let's say I will say one number is 0.45, one number is 0.451, one number is 0.46. So any number. So there are many which are infinite rational numbers between these two decimal points. So I hope this is clear. Moving on to question number 2, circle the rational numbers. So let's go through them one by one, and let's keep discussing that why they are rational and why they are not rational. 3 by 4 is 0.75, so it's a terminating decimal, hence a rational number. 2.72 with a bar, so it shows that it's a recurring decimal, so it is also a rational number, you will circle it. 14 by 4, 14 by 4 is basically 7 by 2, and if I change it into decimal, it is 3.5, so it's also a terminating decimal, hence a rational number. Square root of 90, so as we discussed earlier, that if the square is not a perfect square, the number inside the root is not a perfect number, so then the root is irrational. So square root of 90 is irrational number because 90 is not a perfect square, so we will not circle it. So then 3.6 with the bar, it shows a recurring decimal, so I will circle it. Then square root of 2, so you should know that square root of 2 was the first irrational number invented by a mathematician, and also you can see 2 is not a perfect square, so it's an irrational number. Square root of 13, again 13 is not a perfect square, it's an irrational number. 4.6 is a terminating decimal, you will circle it. Perfect square inside root, so you will circle it. 3 by 11, so if you divide 3 with 11, so let's quickly see what kind of decimal is this. 11 2s are 22, so 8 is the remainder, 80, then 11 7s are 77, then there is 3 30, then 11 2s are 22 again, 6 comes, so 60, so 5 will come, so it's it seems like an irrational number, so because there is no repetition at least up to 3-4 decimals. So 60, then 5 will be the remainder, then 50 44 6 will be the remainder. So then there is still no pattern. Or we can see quickly with the calculator also, and I will get the answer. Our next one is minus 21.2. So it's a negative number and a terminating decimal, then again a recurring number, so then again a negative number. So this is 61 in the root, so it's non irrational number. 1 by 50 is 0.025, so it's rational terminating decimal. Next is square root of 5, so irrational. 3 pi, irrational. 2 by 36 minus 2 by 36 is basically 1 by 18. So we will check this also. So we need to check 3 by 11 and 2 by 36. Then minus pi is irrational. 2 by 5 is rational. Pi plus 5, wherever the pi is coming, that is irrational numbers. 0 is rational. Square root of 4 plus square root of 5. Square root of 4 is rational, but when we are adding square root of 5, so the whole will become irrational. 8.3 with the bar is recurring decimal, so it's a rational number. Square root of 36 is rational, so minus 7.3 it will become, so it's also rational. Minus 4 by 8 is 1 by 2, so it's rational. Our recurring decimal is a rational decimal. 0.3 is rational. 64 is not a perfect number. Oh, it's a perfect number, so it's also rational because answer would be 8. 1000 is a rational number. It's a simple natural number. Square root of 3 is also rational. 1 minus square root of 32. 32 is basically irrational, so this whole will become irrational. 13 is a rational number because it's a simple natural number. Square root of 14 is not a rational number. 7 by 25, so let's see the fractions carefully. 1 by 12, let's see that. So 16 by 5 or minus 7 is rational. Square root of 100 is rational. So this is a rational. Square root of minus 1. 1.36 is again a rational number. So now we need to confirm about these fractions. So 3 by 11, let's quickly see 3 by 11. So I'm opening the calculator for that because I want to be sure some numbers are hidden. So 3 by 11 is, you can see, a recurring decimal. So I will write down 3 by 11 as a recurring decimal. So it's 2.72 with the bar. So then there is minus 1 by 18. So let me quickly check 1 by 18. So you can see it was a recurring decimal and then it is terminating also. So this is also rational. So then 1 by 12 and 16 by 5. So if I check 1 by 12, it also seems like a rational number. You can see that. And then the last one is 13 by, last fraction was 16 by 5. It's also a terminating decimal. So if I say this is also a rational number and this last one is also a rational number. So you can always divide it like this. So you can say it started with 30 and then it is repeating itself, the same remainder is coming. All right, so then moving on to question number 3, which of the following numbers are not rational? So square root of 7 is a rational number, which are not irrational. Square root of 7 is irrational. Square root of 5 is also irrational. Square root of 11 is also irrational. Only square root of 16 is rational because the answer is 4. It's giving you a rational number in the answer. So moving on to fourth question is sort the rational and irrational numbers and place them in the given table accordingly. So let's sort them out one by one. First is square root of 5. So we already know, I have discussed it with you, that if the number inside the root is not a perfect number, so then it will be a rational number. So square root of 5 will come on this side. Square root of 5. So next is cube root of 6. Cube root of 6 is also not a perfect cube. 6 is not a perfect cube, so square root of cube is also irrational number. Next is minus 1. So minus 1 is integer, we will write in rational numbers. So then is 2. 2 is also a natural number, hence rational number. So square root of 4. 4 is a perfect square number, so square root of 4 will be written here in rational numbers. Next is 0. So we already know 0 is a rational number. Next is 3.125. It's a terminating decimal and hence a rational number. Next is 7. 7 is a natural number, so hence a rational one. 4 by 9. So 4 by 9 is basically both. 4 by 9, if I write it like this, it is a square of 2 by 3. So it means it's a perfect square. So it is rational. 4 is also a perfect number and 9 is also a perfect number. Then is minus 2 by 3. So if you can recall minus 2 by 3, so minus 2 by 3 is equal to 0.6 with a bar. It's a recurring decimal, so it is also rational number. So then is 0.333. So this is showing a recurring or a repeating decimal, so I will write down this also here. So next is pi. Pi is clearly an irrational number. Then is 2.67182. So it's a terminating number because neither 3 dots are not there. So I will assume it is a terminating decimal. So I'll put it here. So then is 12. 12 also comes on this side. 4 by 5. So we know that 4 by 5 is 0.8. So 4 by 5 will also come in the rational numbers. So out of these all, I have figured out only 3 are irrational numbers which are in front of you. Thank you for watching everyone. See you in the next video. Allah Hafiz.